I'm Morri Feldman, and I'm from Appsflyer, and I'm going to talk to you about our implementation of GDPR. I want to emphasize that I'm a developer, and so I'm going to be talking about it from a GDPR from a technical development standpoint. So we're here at a big data conference. How many people are working with big data here? Hope I see a lot of hands. So how do you know that it's big? I think for the purpose of this talk, one way to think about whether you're working with big data or not is if I ask you, can you delete a row of your data from an arbitrary row of your data from about a year ago? And you tell me, yeah, no problem. Then maybe your data is not that big. And I hope by the end of this talk to convince you of the technical difficulties in especially data deletion at scale. So what we're going to do is I'm going to talk a little about what GDPR is. How many people are working with GDPR? So a fair number. I won't spend too much time there. I also want to emphasize that as you probably can tell from my accent, I'm coming from the United States, and Appsflyer is an Israeli company. So our perspective on GDPR is as an outsider. We're not Europeans. So then we're going to get to the meat of it, which is how did we implement GDPR in our organization? So what do we do at Appsflyer? We provide attribution and analytics for cell phone applications. So in practice, what that means is if you were to click on an advertisement for a cell phone application, and then go on and install that application on your phone, we would attribute the install and all the subsequent activity from that install back to the original media channel whose ad you clicked on. And this is really important for the people who make ads for cell phones, right? They want to know, are they getting any value out of the money that they're paying to advertisers. I also want to convince you that we're a big data company. We're getting over 100 billion events from the cell phones right now every day. Raise your hand if you think that your data is in Appsflyer. I think you should all have your hands up because given the clients that I know about in our company, you all probably have at least one, probably several of our clients' apps on your phone right now. So that gives us, the equivalent of 2 billion daily active users. Our data warehouse is 60 petabytes and growing. Every day we take in another 80 tera of data, and that's spread out into 150,000 files, and year over year our data is growing very quickly. It looks like we grew 2.5-fold last year, so the data challenges here are pretty immense. But here we're going to focus especially on GDPR, and so as you know, I'm a software developer, but I'm also a person who's just surfing the internet, and so I also care a lot about the privacy of my data on the internet, and I think that we all should. And so it's pretty important that we're protecting data well. So for us, a really important question early on as we were implementing the GDPR solution that we're working on is we need to figure out what is the personal information that we're holding on to. So in terms of the personal information, some of it is quite obvious, like your healthcare information and your name and your address and your income and your race or other cultural features. But other aspects might not be as obvious if you're not in the GDPR space. For instance, the main personal information that Appsflyer is dealing with are device identifiers and IP addresses. Luckily, we don't have to deal with what would be called the highly sensitive information, like healthcare and things like that. So from my perspective as a software developer, what did GDPR do? Well, it gave our users many new rights that they didn't have before the law went into effect. So first off, they have the right to access their data, to see what data we have about them. They have a right to tell us that some of that data is wrong and we need to fix it. That's the right to rectification. They have a right to be forgotten. They can say, it's my data. I don't want you to hold on to it anymore. They also have the right to take their data and take it somewhere else, to another company providing a similar solution. And they have the right to object to specific data processing that we might want to do with their data. I think you can kind of view all of this as under the notion that the user's data is actually their data and we're only holding on to it. And all of this kind of follows from that type of a principle. This is a big time problem if we don't comply with this law. But even without the fines, we're professionals and we have high ethics, and we want to do the right thing as far as people's personal information is concerned. And it's not been completely empty, right? The law went into effect, and already there have been several very high-profile fines that have been levied under the law. So I want to start to dig into the GDPR, specifically who are the actors in this law, and I think you'll see why it's kind of important for us. So in terms of GDPR, the users, they provide the data, and as I said, the data is sort of still theirs even when we're working with it. After that, you've got what's called a data controller. So this is someone who actually controls the data that they're getting from the user. And then there are third-party data processors that process the data on behalf of the controllers. And in our case, Appsflyer is a data processor because we have no direct relationship with the users of a cell phone application. We only interact through our clients are the people who build cell phone apps, and we interact with our clients, and they happen to interact with the users. So you might think, oh, this is great. We're a processor, so we don't have to worry so much about GDPR. Actually, it's kind of the opposite, right? Our clients, the people who pay us money, they have the strictest requirements under GDPR, but how are we going to get clients if we can't offer them a solution that satisfies the legal requirements of the law? So in that sense, it may seem a little surprising that GDPR at our company was developed as a product, as a feature, sort of the same way we would develop any product or feature because it's really a client-facing issue for us. So let's dig into the Appsflyer architecture. So the way we get the events from the cell phone is that our clients embed our SDK into their cell phone apps, and those SDKs are constantly sending us events. At the same time, we're getting clicks and impressions from the web, and the combination of install events and clicks and impressions allows us to attribute the install back to specific advertising. All of this goes on in a sort of a real-time part of our system where the main data stores are Redis caches and Aerospike databases for those who are interested. And finally, this type of these events, which are now enriched with their attribution, meaning which media source provided the advertising, are put onto a message queue. And then down in my team in data, we receive this data and persist it to two large data stores, one a BigQuery data storage, and then also into a large data lake on S3 that consists of loose Parquet files. And so the rest of this talk is going to be about how we deal with the GDPR requirements in this data lake setting. So specifically, I think the hardest thing for us to figure out how to do is how to delete data. So this might not seem like a big issue for some of you, depending on your background, but if this was 20 years ago, it probably would not have been a big issue for us, right? You would go to your database and you would say delete from XXX where user ID equals somebody's user ID, and they would be gone. But the modern data infrastructure is not the same as it was 20 years ago. Specifically, most of the storage is based on the fact that we're receiving time series immutable data that's never going to change. So we receive data, we file it away in large, highly optimized chunks for querying later on. And then if you ask someone, go into this large chunk of data that's never supposed to change and delete a single row, now you have a problem. And that's where we got to. So kind of as an earlier step, we needed to figure out the scope of the deletion issue. And according to the GDPR law, at least our interpretation of it, I'm a developer, so pay attention to the technical stuff, but we interpreted the GDPR law to mean that data sources in our system that persist for longer than 30 days, those are the ones that we need to worry about deletion. And if we're already rolling over the data and removing it before 30 days, then we can not worry about those parts of our system. So our messaging queue is ephemeral, so we don't need to worry about it there. But these two data sources, we keep data for a while, and so we need to figure out how to delete them. So at the time that we were designing this feature, we really investigated a couple of options that I'm going to outline here for how we're going to be able to delete old data. So the first one I'm going to go through is well, we'll just keep the personal information separate from the rest of the data. Another option is that we store the personal information with the data, but we encrypt it in a way that protects it. And finally, the last option might be to just do nothing. And when you need to delete, go through row by row and ask delete, no, and deal with it that way. So for the first approach, you can imagine we have data for each unique user in our system in several different tables. And instead of storing their personal information with the rows of data, we would store it over here. And these would be individual personal information fields, IPs and addresses, which we don't have, but things like that. So the advantage of this is it's pretty simple to reason about, right? You have all the data in one place, you can control it, but one of the big problems is that we have many different jobs that are all reading this data that already exist in the company, and we would have to adapt every job to be able to read this data. And furthermore, this is a huge join. So if you remember, we're basically tracking nearly every user of a cell phone in the world, so this table is enormous. And so if every time you have to do a huge join, that's a really problematic data processing step. So we didn't go that route. Another option is to encrypt the personal information in place with a specific key that's a different key for each user in our system. So deletion now is really simple and very elegant, right? You just throw away the key, and now if you want to read that user's personal information, you can't do it because you don't know their key. But again, it's a huge join because now you need to, for each unique ID, you need to go and get their key. And now you have to have special code that can decrypt each row with a separate key. As you might imagine, this is also a little bit frightening. If you were to say push a bug in this part of the system, you could easily render a whole portion of data unavailable for anyone. And so that's also pretty frightening. So a third option is just to do nothing. When it comes time to delete, just go row by row through these enormous data stores and delete the data. The big advantage here is that all the jobs that we have, we don't have to change them. But maybe there's something we can do a little bit better than scanning 60 petabytes of data every time we need to delete someone. So as I was analyzing this problem, I realized that in our system, each unique user only touches a couple of files every day. So what you see here is that most users, 2 billion of them are only touching one file, and then the rest are only touching a handful of files every day. So this leads to an optimization strategy, which is that we can index the users and keep track of which files each one is touching. So just to remind you that the structure of our data is just one Parquet file after another. Parquet is a highly optimized columnar data format, and each file is just coming in serially from the outside world. So what we do is we go into each file and we just ask for all the unique IDs, and we store them aside for each user. So what are the challenges with this type of approach? Well, one is we still have to scan the data every day to build this index. This is a kind of a pseudo SQL for what this looks like in Spark SQL, which is where we implement this this transformation. And just as a side note, we're able to use this function input file name, which for every row of the data gives us back the file name where that data came from. Without this function, it would have been pretty hard to think about how to do this indexing. And I think this function is the only function in Spark SQL, or probably Hive SQL as well, that I can think of that gives you back metadata rather than data. So if anyone knows of any others, I'd be interested to know. So one thing that's a little bit difficult here is that we have many topics, we call them, of data, and each one can have a different schema, so we need to maintain some data about where to find the unique IDs in each file. And there's a synchronization problem. If we have a bug, and I go and I fix the raw data, now we have to fix the index too, so we need to tie those two processes together. So in practice, what does this actually look like? So from our APIs that we provide to our clients, we get a list of users that need to be forgotten. We go to this data index and we find all the files that any of these users touched ever in the past 2 years or so. First thing we do is we copy all those files aside. In case we mess anything up, we don't want to break anything. Then we go one file at a time and we delete the users out of that file that need to be forgotten, and then we write the file back. This may seem a little weird to you, but remember that these files are not a flat data format where each row is a separate position in the file. These are organized into highly optimized columnar data structures, and that's for query performance mainly. So you can't just go in there and edit a single row, and because the data is sort of distributed. And then after we've edited the files, we run some tests on them and do some sanity checks. Did we delete the users we're supposed to? Do we still have data in the files for the users that we're not supposed to delete? Stuff like that. And then finally, we put the data files back into the data warehouse where they came from. So when we were developing this as a product, great, thank you. We were told we might have tens to hundreds of requests to delete user data per month. And that informed some of our planning, but luckily we were still a little bit more careful than that. And actually we're getting 400 requests to delete 400,000 users a month. So to do that, we still have to scan a petabyte of data. But as you remember, we have a 60 petabyte data warehouse, so this is still quite a serious optimization. And we have to look at 8 million files that we're copying back and forth through this process. I'm going to skip the BigQuery part and just want to close with what we've gone through. And so from a developer perspective, I hope I've sort of given you the GDPR concepts as we see them from the trenches. And it's very difficult to delete a single row of data in a modern data architecture, at least for the current data architectures. So we took a very pragmatic approach. I'm hoping that new data architectures will come out that make this a simpler problem. Specifically, there's new systems coming out that can simulate mutability over a collection of immutable files. These are things like Hootie and Iceberg, and Databricks has a similar solution for Spark. So I think those are going to help in the future, but they're still in the drawing board. So, well, thank you, everyone. It's been a pleasure.